Today we're going to talk about the SDS011 particulate sensor that is used to measure air quality. We're going to install this along with an ESP8266 using ESPHome and get that all configured into Home Assistant. We'll also even put together a Grafana Graph showing the trending of the air quality. So let's jump over to the bench and let's get started. Before getting started with the actual construction or putting together of the device with the ESP8266, I want to talk about a couple of specifications on the device and some details. This is a PM2.5 sensor. It's a product model SDS011, a device that uses a laser scattering and gets particle concentrations between 0.3 to 10 micrometers. And it has a digital output, has a built-in fan. It has a response time of less than 10 seconds. It has easy integration using UART, and we'll be using the UART bus on the ESP8266 for this, and it has a high resolution. This uses a laser light, brings particles in and measures them via a laser light inside the device. And one of the important things to think about when you're talking about particulate sensors is the service life. It's a key parameter of a laser type dust sensor. The diode in this sensor has a high quality. Its service life is up to 8,000 hours. So if you need real-time data, you can use the default configuration. It measures it every second. So we're not going to measure every second. We don't need that kind of granularity for what I'm doing. So we're going to measure once every 5 minutes. And by doing once every 5 minutes, it prolongs the life of the device. So the first thing we're going to do is we're going to go ahead and program the 8266 board with the proper settings so that we can measure with this device. Let's get over to ESPHome in Home Assistant and we'll take care of that now. Okay, so what we need to do first is we need to go into ESPHome, and I already have this set up on my Home Assistant instance. You need to make sure that you have ESPHome installed and running. And if you've watched other videos, you see that I have other stuff already going here. I already created an air sensor configuration. And so I'm going to show you how the configuration looks here, and then we'll flash it over to the ESP8266. So clicking on edit, we'll go through some of the settings here. Obviously, the name is what you give it here, air sensor, platform ESP8266. And when you first install this, let me show you here. When you first install this, there's a little button down here and you click on add. You'll name it, you'll do your Wi-Fi SSID and Wi-Fi password, and it creates this initial configuration file for you. So we're going to go back into this and look at that now. And that's where it sets the name and the platform and the board. Now the board name I changed because I needed the pinout to be correct. It defaults to a different type of board than what I have. I have the Mini or the D1 Mini. And so I had to put the D1 Mini board as a specification here. The other thing to think about or consider here is since you're using UART, you're going to want to use set the logger baud rate to 0 so that it's not sending out the logger information over the serial port on the same port that you're sending out your UART data from the sensor. So make sure you set baud rate 0 here. It already has an entry for logger. It just doesn't have this baud rate 0 specification. Then you'll do your Wi-Fi SSID and password, which you can configure in the wizard like I just showed you. I use a secrets file, and if you come up here with this closed and look at the secrets file, this is where you can put all your secrets for stuff inside these configuration files. This is not the same secrets file that Home Assistant has. This is a secrets file specific to ESPHome. This is the part where you need to specify what you're going to set up here. Now, if you look at the particular information under ESPHome, this is all the information you need. Now, this is the data sheet, and this is what I showed you earlier. It's got all the information in here that you need if you want to learn how all of this works with that sensor, the sizes, the inlets, outlet fans, all of the stuff that you use specifically to this or specifically for this sensor. But we're concerned with the configuration here in ESPHome. And so this is already set up for you with some changes that I made. So this is an example configuration entry. And the changes I made, essentially I just copied this and I pasted it over here in my configuration file with some changes. You can rename the name of the sensor if you want to. I left it as the default particulate matter less than 2.5 and particulate matter less than 10 concentration. The update interval is set to 5 minutes. That's important if you want to prolong the life of the device. If you don't specify this, then what will happen is it will send you updates every second. And I don't think necessarily you need that or want that. The other thing I changed was the UART pin for this device. The D1 Mini has a number of pins here, and the receive pin and the transmit pin are specified in order for it to be able to control the refresh or the update interval. If you read through the documentation here, it says the update interval, the working period of the SD11 will be changed. If update interval is equal to 0 minutes, the SD11 will be set to continuous measure and will report new measurement values approximately every second. If you set it between 1 and 30 minutes, it periodically turns on for 30 seconds before each measurement, and then it shuts off for the remaining amount of time. This can reduce power consumption and increases the lifetime of the SDS11. That's the other thing I didn't mention, is it also reduces your power consumption overall. Now, if we look up here, the communication is done over UART. So you have to have the UART bus in your configuration, which is what we have specified here. You have the receive pin connected to transmit pin of the SDS011, and optionally the transmit pin connected to the receive pin. You need to set the baud rate to 9600. Now you need both of these pins because what you need to be able to do is you need to be able to tell the device to turn on or off. If you don't have this, the update interval is not going to do anything. So make sure you have receive and transmit specified in your configuration here so that it can control the device and turn it on or off and get those measurements and prolong the life of your device. Here's another note. The configuration variable update interval reconfigures the SDS011 device. The setting is still effective after power off. This can affect the performance of other libraries. The factory default is continuous measurement. So just keep in mind, if you're doing other stuff on this same device, it may be affected by the update interval. It may be worth your while just to use a dedicated ESP board for this measurement so you can set this and not affect other libraries on the board. Okay, so once you have this all set up, then you can save it over here on the right. I'll click on save, close this, and then over here under validate, you would want to validate it again. And it'll come through and tell you that everything is valid. It gives you a green check mark. And then you can just install it from here. Now I've already got it installed on the device, and I've had it up and running for a little bit just to make sure the sensor works. So what we're going to do now is we're going to go on over to the soldering iron and we're going to wire it up. It's super simple. And then we're going to get it up and running in Home Assistant once it's wired. And after that, we will show you a little bit of the measurements and show you some Grafana graphs that I have built, or a Grafana graph that I've built. So over to the soldering iron, and let's get started on that. This particulate matter sensor comes with a couple of cables. You can see this one here, and it comes with another cable. The difference is that they have different ends on them here, and I probably see that a little bit better here. You can see that these cables have different types of ends on them. This one is a female end, and there's another cable that comes with it that actually has the male ends. But because it has the female ends on it, what I'm going to do is I'm going to take this right here, and I'm going to solder this on the board. Everything we need is on one side. So I'm going to solder it on this side of the board, which means I need to flip it over. And that way we have the ability just to plug it in without having to do any extra stuff with it. So the way I'm going to do this is I'm going to get this thing down as far to the ground as I can get it, and then I can just set this in the connector and make sure it's even. See if I can get that started in there. Just set it down on here. This is where you need 3 or 4 hands. Get it to sit down there like that. And then I can get it started, and then I can come back and add in, get it to stay there. We're going to just get these started and then make some adjustments if we need to. So I'll hold that there and use 3 or 4 hands to hold this in place. Just want to touch the solder on there, not too much. You want to burn the pads. I'm going to get that one started, and I'm going to do this one on this other side. And that way we can just hold it in place with the 2 soldering pads, and I can go through and touch the rest of them up. So that one looks good there. And we'll just kind of touch it in here, actually. Yep, that one's okay. That one looks okay. Just put a little bit of solder on it, on each of these pins. Really see that one. A little flux one on that one. Do this one again. And everything we need is just on this one side of the board. Receive and transmit, and then we also need the ground and the 5 volts. The power for the particulate sensor is actually going to come from the 5-volt plug on this board. Let's get those all soldered in like so. My helping hand keeps moving. It's supposed to be in one spot, but it moves. And one final one. All right, let me just get this one again. It doesn't look like it has enough solder on it. Okay, so we have all of our soldering done. That makes it super simple to be able to solder this in place. Let's look here and see what it looks like. Take it off of here. All right, so we have our solder for all our pins on here. A couple of those could look like they could use a little bit more solder. Let me go ahead and hit the D2 and D1 and even the 5 volts. So let me just touch those up again. It's a problem when you get old like me. You have problems with seeing stuff with your glasses off or on, as the case may be. So let me just tap a little bit more solder onto these and make sure that they're nice and covered with solder. And I turned off the soldering iron. There we go. So just give it a little bit more. What I'm trying to do is prevent actually damaging the board by getting it too hot. So I'm just barely touching these to make sure they have a little bit of solder on there. All right, that looks a lot better than it did a minute ago. All right, let's take it off and take a look. Okay, so we have all of those soldered on there. They look nice. And so what we have now is we have this header board here, or this board. I guess it's called a header. And all we have to do is then take the cables, and I misspoke a minute ago. This is a female board. They actually, with these ESP8266 that I bought, you can actually solder on the male board or the male header, and then you could just plug stuff in directly. The good news is this device actually came with 2 different kinds of cables, and so we actually have a male terminated cable here that we can just plug into here. So we want receive and transmit, and we'll look at the back side of this board here. Let's go ahead and plug this in. You can see that this is keyed here, so it only fits one way. So we'll just plug it in this way and snap it in. So it's nice and snapped in there. And on the back side of this, it comes noted with the pinout. And because it does, you don't need to do a lot of extra figuring out where things go. So we want transmit, which is this blue one. We want receive, which is this green one. So these are our 2 data lines. Get those untangled there. And then we also want ground. So ground is the black one. That makes sense, because typically black is ground. And then we want our 5 volts. So our 5 volts is this red one right here. And so we're going to use that one right here. Now the rest of these have other purposes outside of our application today. So we're not going to use those. We just need these right here. Now remember, when you hook this up, you need to invert transmit and receive, because you're transmitting from this board and receiving on this board. So you would have transmit out here. If I could focus, transmit out on this one. And then you would have receive over on this board right here. So let's find the receive, because I'll take the transmit out of the sensor and I'll plug the receive in here. So this second pin is receive. So I'll go ahead and plug it in here. And then of course, green is receive from the sensor and transmit from this board. So I'll plug that one in here. Then we have our ground. Let's find ground on this ESP board. Ground on the ESP board is this second pin right here from the, what is my left here. You focus on it, there we go. There's ground, and right next to it's the 5-volt pin. So you've got ground and you've got 5 volts on there. And so we're going to use both of those here. We've got ground going here, and then our red here is our 5 volts. We'll plug that in. So here we have 3 pins that aren't used, and we can just kind of tuck these away. You probably want to terminate these or cover them up so they don't get shorted out or anything. We'll just kind of tuck them away like this for now, so we can see what we're doing. So here we have, on the back side of this board, we have our transmit receive 5 volts and ground connected to our transmit receive and 5 volts and ground on our ESP8266. So now the next step is to go ahead and plug in this 8266. I'll assume that you already have it programmed. You already sent the information configuration that I showed you a little bit ago into the ESP8266. And with that, we'll go ahead and get this set up in ESPHome or in Home Assistant. And with that, we'll start getting some measurements. Next step is to plug this into a power source. I'm assuming, again, you have Wi-Fi hooked up, and the Wi-Fi is what you're going to talk to it. You don't actually need to plug it into the PC that you're using. All you need is power now. And by powering it, it should start sending data out at that 5-minute interval. Now, I don't think it sends the first packet out until 5 minutes. So you're going to have to wait a few minutes for it to actually do something once you power it back up. So I'm going to get it powered up, and then we'll jump over into ESPHome. I'll show you one final step you need to do with the integration part of it, because it's got to be detected first. And then after that, you should start seeing data come from the device. All right, jumping back into Home Assistant here. If the air sensor or your new device, whatever you called it, is on and operating correctly and on your network, it should be shown here. And you can see that it's clear. If it's red, that means it's offline. If it's blue, or says update available, it's on, but it just needs an update. In this case, we have the latest update, it looks like, and we're ready to go with this. So you can look at the logs to start off with and make sure it's doing what it's supposed to. You want to connect wirelessly if that's how you've got it connected. It'll take a second here to show you the logs. And what you're looking for is to make sure that it sees these sensors here. So it's got a particulate matter sensor for both the 2.5 and the 10.0. And again, the update frequency or update interval you set will determine when it sees the updates. So sitting here, you see there are no updates yet because mine is set to 5 minutes. It will take up to 5 minutes for my first particulate sensor reading to show up. Now, what you can do while you're waiting for this to send its first update, in fact, what you need to do is you need to make sure that it's showing as an integration in Home Assistant. Typically, it will get discovered as an integration. And so you'll see a notification like this over here. It'll say new devices discovered. Click on check it out. And you'll see here that it's discovered the air sensor for ESPHome. You can click on configure. It'll ask you if you want to add the ESPHome node air sensor to Home Assistant. You say submit. You can give it an area or not. And then you'll see here, it should show up in your list. And where we have air sensor now, we have one device, 2 entities. Those 2 entities are particulate matter sensor 10 and particulate matter sensor 2.5. So let's go back over to my production Home Assistant and we'll look at the developer tools. Developer tools is always a good place to see if your sensors are showing up here. So what I want to search for is particulate sensor, and see if I have anything here. So I do. I have a particulate matter sensor concentration of 58.6, which is pretty high actually, and a particulate matter 2.5 concentration of 21.1. Now these were done, oh, you know what it is? So I was soldering in here, plus I have the door closed, and it is automatically registering a higher concentration of matter than when I was looking at it earlier. And I can tell you that by looking at our Grafana graph. So now let's go over to Grafana and let's see what we can do with this. I already have created a Grafana graph, and I'll show you how I went through and did that here. So under environment, you can see here already I have the particulate matter running, and I have had it running for a little bit. But to create a graph like this one, all we need to do is go into and add a panel, add an empty panel. And what you're looking for is you're looking for an entity ID. You can select the measurement first if you know what it is. I didn't know what kind of measurement it was storing this under or how to search for that. So I went for the entity ID first. So I'll look for entity ID. Let me drag this down a little bit and I'll select the tag value and I'll search for particulate matter. And we have both our 10.0 and our 2.5 here. Let me click on 2.5. And then you have to select the measurement over here. It knows the entity ID, but it doesn't know what measurement to use for that entity ID. And this is where it gives you the proper choice. And you'll start to see your updates here if you've got the right kind of query set up here. And then you can do a lot of stuff where you're setting different values and things here. Let me shrink this a little bit for you. And then we can add our 10.0 concentration as well. So it's same exact process, entity ID, and I want to look for particulate matter, and that's the 10. And my measurement's going to be in the same measurement, or same type of measurement. And I'm going to give it an alias because we need to know which one's which. So this is a 10.0 concentration or 10.0 concentration. This is a 2.5 concentration. So we have those here. Now you can see 2.5 and 10.0 here. What I like to do on this is I want to go over here to the right-hand side and I want to have a legend and I want to choose the value of the legend. So last non-null value, so I can see what it is here. And I also like to have my null values connected. So instead of having these dots, I like to have a nice complete graph. And this is what happens when you set that. You can do all these settings. These are all personal preference settings on how you want it to look. If you want to look up what the value is for healthy measurements for these things, you can come down to the bottom here. You can actually add these thresholds. And I think 35 or something might be a value. So if it gets above 35, and then I turn on the thresholds as lines, I have gone above the healthy threshold for this value here. Now the thresholds differ between 10 and 2.5 concentration particle sizes. So you'll have to play around and either create a different graph or not use this. But anyway, it's a reference point, gives you an idea, you know, what kind of level you're getting and at what point it becomes unhealthy. So this is very interesting that it shows basically me soldering in this room with the door closed with not a lot of ventilation and spiking these values. And then of course, when you're done with all this, you just click on apply or save and save the dashboard. And this gives you your dashboard. So we have a particulate sensor now measuring our air quality within the house here. We have added it to ESP8266. We have also set our refresh interval to save, or update interval to save the lifetime of the sensor or extend the lifetime of the sensor. And now we've done a little bit of Grafana work. So I hope that was helpful to you. If you have any questions, put those down in the comments below. Hit me up on Discord, and we'll see you on the next video.